Hey guys, welcome to day 28 of Codeforces Every Day until GM. A few updates. As y'all can see here, I reformatted my repo to have it like problem A, B, C, D in that order because I now have an extension that auto creates the files for me and brings up the test cases. So for example, just pick random question. As you can see, these are the test cases. I can click on the problem. The test cases are automatically in my VS Code. I can add new test cases and I can submit it directly from here. I also have an additional extension that allows me to submit stuff directly from VS Code. So yeah, um, without further ado, let's get started, I guess. And so what I can do is I can press this extension button here and it will just generate it for me. I no longer have the link to the question in the problem anymore since they're linked like through the extension, but I still put the rating in the thing. Just saves a little bit of time, you know. So rating like that. Alright, let's get started. Santa lives in a city that has inn houses built along the main road. The ring road houses are numbered 1 through n in the clockwise order. The ring road traffic is one way and is also clockwise. Zena has recently moved into the ring road house number 1. As a result, she got M things to do. In order to complete the I task, she needs to be in the house number AI and complete all the tasks with numbers less than I. Initially, she's in house 1. Find the minimum time she needs to complete all her tasks of moving from a house to a neighboring one along the ring road. Takes 1 unit of time. Okay. First line takes in 2 integers. Min equals map int input dot split. And then next line takes an array with m integers equals list map int input dot split. Print a single integer at the time Zena needs to complete all tasks. Okay. Let's take a look at the note. The first test case. 1, 2, 3, 4, 1, 2, 3. 6 unit. Wait, okay, what is going on? So okay. Zena lives in a city that has inn houses. So it has 4 houses. Zena has recently moved into the first house. She got M things to do, so she has 3 things to do. In order to complete the I task, she needs to be in the house number AI and complete all the tasks with numbers less than I. Initially, she's in house 1. So she has 3 tasks, there's 4 houses. I'm confused. What is... M things to do. There's 4 houses, she has 3 things to do. Okay, so... First test example. The sequence of Zena's moves along the ring road looks 1, 2, 3, 4. 1, 2, 3. I'm kind of confused on what they are saying here. She has m things to do. In order to complete the ith task, she needs to be in the house number AI. Okay. So these are the tasks? So 1, 2, 3, 4, 1, 2, 3. And then this one would be 1. So this is 6. 1, 2, 3, 4, 5, 6, 7. This is 7 time units. I guess she starts from house 1. Right, so it's 1, 2, 3. Okay, I think I kind of get it. So for, well, it's while I alright, time equals 0 while len a greater than or equal, well, len a is greater than 0. And keep going, and then index equals 0. Um, and if we check, well, every time we go through the loop, we increment time, right? And at the end, we're printing out time. Time plus equals 1. At the end, we're print time, right? And then what do we do? We need to check that, like, removes A from the list. And we need to, like, loop the index somehow. We do if for I in A. No. Index, if index, wait, we can take care of multiple in 1 unit of time. So if we have a queue, we queue up Wait, I'm confused. Why can't I visualize this? Let's bring up Excalibur. So we have a list. 3, 2, 3. This is our tasks, and then we have number of houses, so 4. Something like this. And then we increment time and index. Or we check, so current index equals 0. If let's move this a little bit, we're in the way of another problem I did. Index equals 0. Let's do index equals 1, because then we can do if index is equal to n, index equals 1. So if index n index equals 1. So that solves that problem. And then before this, if index is equal to a zero, a dot pop 0, and then so now the problem becomes duplicates. Right? we're going to do while index equals a0, a dot pop 0, so this should pop duplicates. Let's see. I don't know what sigterm means, but I suspect it's an endless loop or something. Yeah, okay. While len is greater than 0. Len a. So we're just never popping everything out. Index is 1. So let's print len a here, and let's print len a index a. Oh, oops. Three, 1. So len a is 3, index is 1, and then a is this. So we're saying index is never equal to a0? That's not true. Len a index is 1. Oh, I should increment index in here. Or we should do it like if index equals n. No, it's index equals n plus 1. Index equals 1, and then we do index plus equals 1 here. So index out of range. Three, 2, 3. Okay, let's do a like this. 3, 2, 3. Or 3, 1, 3. 3, 2, 3, 3. 3, 2, and then len is 2. index is 4. Okay, 2, 1, 2, 3, and then 2, 2, yes, and then 3 pop. If there's nothing left in our array, like that, seven. It's because I incremented this last time here. Three. Hmm. Do we add one more check here, like this? This seems mildly repetitive, but it should work. Right. Yes, now I don't like this part. I don't like having the double while loop and the double if statement that does the same thing. But it should, okay, it fails on, it's because I have this print statement here. So now it should pass this. Okay, it did pass. Now how can I clean this up? Because I'm not submitting it with it looking like this. Index time. And then number of tasks. Oh, we can do like task equals 0, and then while task is less than m, then we can check while task is less than m and a task is equal to index. We should really rename index. Index is house number. Rename index to house. And time. House task time. Well, task is less than m while task is less than m, and a task is equal to house, then we can increment task by 1. And then if task is equal to m, we can break, and then increment house by 1, and then if if house is greater than n, then set house equals to 1, and then time. Okay, this should work. Yes. Alright. Let me just double check. Task is less than m. Well, task is less than m. Well, task is less than m, and a task equals house. So that's this case, right? Task is, here we should print task. So we're at task 0. All task is less than m, and a task, so 2, is equal to house. We're at house 1. So the second doesn't hold, so we move through. So back to here, task 0. Still, but our time is 1, and we're at house 1. Or house 2. And so we're still task 0. Task is less than m, yes, and task 2 is now equal to house. So we increment task by 1, so we're at task 1. House 3, time 3. Okay, yeah, I think this works. Now, I'm worried about this double while loop here. Makes it quite slow. Although my old code was definitely O(n squared). Well, task is less than m, so it's O to the m. This first one's O to the m, and then while task is less than m, and task equals house. So basically we're checking at most it's 3, 3, 3, 3, 3. Like input, say we have 5 houses and 5 tasks, and then we'll just do our expected output would be house 1, house 2, house 3. So 1, 2. Alright. So should be correct. Submit it and see. This question took quite a while. It's 1000 rated. Uh-oh. Something has broken down in Codeforces. Is Codeforces down? There we go. We're in queue. Still in queue. And take a look at the next problem while we are in queue. Rating's 900. Magic number is formed by concatenations of numbers 114 and 144. We can use each of these numbers any number of times or magic numbers, but are not, okay? You're given a number, determine if it's magic or not. Okay. Okay, so n equals int input. TLE. We got a TLE on the earlier question, so let's take a look at that. Which is this part, right? Okay. Can I go the other way? Because it's a ring, right? Because I didn't actually take into consideration being able to go like this. Like, I thought about this, but I didn't think about it. You know what I mean? Uh, hmm. Okay. Well, we're basically simulating, right? It did say implementation. Can we do this with math? Like, usually when you can't simulate, you can do it with... You can try with math. So... Let me close out of all these duplicate. Let me take a look at this. So we can track our current house. Let's do like our current house is here. And we look through A. Let's say A is 3, 2, 3. Or let's do like 3, 3, 4, 2, 3 or something. Like that. And then our first target is 3. So our time is going to be 1, 2. So it's time plus equals target. So this is A I minus house. And then we set house equal to I. Wait, we set house equal to uh AI. We set it equal to I. No, that doesn't make sense because I is 0. So we set it to AI because that's 3. And then now the next is the same. So AI would be 3 again, house would be 3. So we add times 0, and then house would still equal 3, okay? Next is 4. So 4 minus 3 is 1. We add 1, house equals 4. Next is 2. So 2 minus house is 4. 2 minus 4 is negative. That's not right. We're looking for here, but we're here. So we should do uh we should do n minus current. So n is 7 minus 4, that gets 1, 2, 3, and then plus it's 4, 5, so it should be 5. So plus 2, this is 7 minus 4, which equals to 3, plus 2 equals 5. So there's two cases here. Case 1, case 2 is n minus house plus AI. And this happens when if okay, so this is house less than AI. House less than or equal to AI. This is house greater than AI. So we can just do if this, else this. So yeah, that way we don't have to simulate everything anymore. Let's comment this out. So what do we need? We need a house. We need to track house, and we need to track time. And I think we can track task with a for loop. So house 1, and we times 0, and then for task in A, if task is greater than or equal to house, then time plus equals A, or time plus equals task minus house. Else time plus equals n minus house plus target, or plus task in this case, and then our current value of the house would be equal to our target value in the array, which is our task, and then we print time. That's it. Now this is one pass. This is O of m instead of O of m squared. This works, right? If task is greater than house, so we're just checking every task, basically. Then we add time, else. I think this is it. Okay. Wow, this question definitely took way too long. It's a B question. It took me 45 minutes. I'm gonna bookmark this one. Okay, there we go. Magic numbers. So we took an input, and then magic numbers number formed by determine if it's a magic number or not. First line of input contains an integer in. Yes if it's magic, no if it's not. Okay, so we can use the numbers 114 and 144 any number of times. It's greedy and brute force. So I think what we do is we greedily choose 144 and then we dot remove it, and then we do 14 and then we do 1. And if there's leftover stuff, then we print no. And if it's empty string, then we print yes. So I think what we can do is we can take in a string instead, and numbers equals 144 141, and then for okay, and then for in numbers, if we do s dot or in dot, okay, for num in numbers, in dot remove, in dot replace num with empty string. If in equals empty string, print yes, else print no. Okay, so this messed up. We received the output no. So we greedily chose 144. That didn't work. I want to see what in looks like after this case. On what? Why is this not working? Oh, give me a second. Let me just test. In dot replace. 14 with empty string. Print in. Oops. That didn't work. Why didn't that work? Dot replace. Do I need to do n equals in dot replace? Like n equals, that might be the case. Yes. So this is right. I just need to do in equals in dot replace. It just failed because I have this random print statement here. Still failed because I have this random print statement here. There we go. There we go. Okay. Or I can do this thing now. So it definitely went a lot faster than the earlier one. Wrong answer. I do not like that I'm wrong answering quite often on these easier questions. So this. 3 answers. We failed this. Now the question is why did we fail this? So we could readily choose 144. Right, let's print in after every chooses. And then we're left with this. So jury answer is no. We greedily choose 144, so we're left with 114, which is 14 and then 1. There should be yes. Why is this no? Expected no, found yes. Oh, is it because they have to be in order automatically? So, okay, this does make it harder because like this 4 here and this 1 here. Okay, so for this number, we greedily choose 144, right? But then we get 14 with Jesus. With these two, but since these are not like next to each other, then this doesn't work. So that doesn't work. So we need a new strategy. And I'm thinking of a new strategy. I don't know. We could like try to for loop the front. Uh what can we do? One 14, 144. So the number can only have ones and fours in it. so 114 and 144. Combinations. Have 1, 4, 1, 1, 4, 4, 1, 4, 1, 1, 4, 1, 4, 4, 1, 4, 4, 1, 1, 4, 4, 1, 4. Okay, so these are all the possibilities of numbers that we can get, or combinations of stuff that we can get. Like if, or I guess I forgot about 1, 1, 1, 4, 1, 4, and then 1, 4, 4, 1, 4, 4. This is all the number combinations we can get. And so, what can we learn from this? Can we ever get 3 1s? Yes. Can we ever get... Well, so, okay, so if n has numbers other than 1 and 4 in it, how do you check that in Python? If check if string contains specific strings. I can use in, right? Check if string contains check if string contains only the digits 1 and 4. Use regex. So I guess what we can do is we can iterate through in. Let's comment this out. Also, here's the thing. All these numbers start with 1. So any combination of numbers will always start with 1. Ugh. That's interesting. I also really need to use the restroom, so I guess I'll try my best to hurry up and finish this question up and I'll end the video. Only doing 2 problems today, which is a little bit unfortunate, but these problems are stumping me. So the number can only be made up of 1s and 4s, and the only pattern... Okay, we can at most have 2 4s at a time. Because, yeah. We can't have 3 4s. So we can count maybe... Count 4 equals 0. And then 4 in 4 digit in if n equals 4, if digit equals 4, it's a string, so like this, count 4 plus equals 1. And then if count 4 okay, well, first of all, if it's 1, else we reset count 4. Or equals 0. 0, 1, 4, 2, 4. And then if count 4 is equal to 3, then we just break. Well, okay, so we can have a check. It's like, on if n o is not equal to 1, print no, else What if we just track a 2 print? The string 2 print. Do 2 print equals no. 2 print equals yes or no. We just by default do 2 print equals yes. We'll go through at the end and we'll just print 2 print. Right, start with yes, and then we check every digit. If digit equals 4, if we hit 4, we do this, else we reset count. And then if it's at the end, okay, yeah, this should work. Okay. Submit. Let's go. Wrong answer on 9. Well, I failed an even easier test case this time? Are you kidding me? Test case input 1000. Expected test case is no. We get a yes. Oh, we never checked for digits that. So, okay, we need to do elif. So we checked it if digit is 4, if digit is 1. Then we do this, and then I need to use the restroom so bad. But I am about to re-record this video, so there's 1 and then else. Print no break. To print, it's this. If we get any, it's basically saying if we get any other digit, we break as well. Alright, so there we go. Okay, please work. Why did not? Hello? Oh. I have submitted. Oh, did it work or? Give me a sec. Oh, wait. Load. There we go. We got it. Alright. If you like this video, be sure to like and subscribe. After I run to the restroom, I will record the CSES problem set. So look forward to that. Day 2 of that. And yeah, I'll see y'all guys tomorrow. Bye.